if R and F are in the plane of rotation, and the torque is along the line of omega, okay? So the line of omega doesn't change. Why not? Because the torque is along the line of omega, so is the angular acceleration. So any change in angular velocity will be along that line.
This is if it only rotates in one plane, right?
That follows from the assumption that the line of omega doesn't change. Okay? Now, this applies, though, even if the line of omega does change. Okay? Now, so I can say that if torque isn't, net torque isn't in not in the line, I'll say along the line of omega, and alpha won't be along that line. So the direction of omega will change. Okay? And of course, you experienced that because what we did was rotated this thing and then applied a torque in this direction. Okay? Now if you think of that torque as being a force here with the R vector here, then R cross F is this, right? Or if you just think of the torque wanting to rotate the thing in this direction, then you can use your right hand and say that's the direction of the torque. You can see it through R cross F, or you can see it through the right hand rule because we're trying to rotate about this axis, right? So we have an angular velocity in this direction and a torque in this direction. So what's going to happen? Well, I get the thing spinning and then I try to look at what happened. The plane of rotation changed. The angular velocity, direction of the angular velocity changed. It was here and now it's here, okay? And it changed exactly according to the resultant of an angular velocity vector in this direction and an angular acceleration vector in this direction, okay? Now the actual change, you know, the angular velocity kind of went from here to here, and the tip of that angular velocity vector didn't take a straight line from here to here. It kind of had some curvature, okay? And we're not going to actually work that out, okay? Because what happened was the angular velocity kept changing as the torque didn't exactly, but kind of remained the same, okay? So you have this angular acceleration that accumulated changes in angular velocity on top of previous changes. And that's a little bit complicated, although using a little multivariable calculus you can easily set it up and just see what the angular velocity as a function of time would be. Kind of interesting, but beyond what we're going to do in this course, okay? But at the next level, well, that's why we study multivariable calculus, okay?